All right, let's get rolling. Everybody online can see my screen and hear me. Is that an accurate statement?
Yes.
All right, perfect. And I am recording. So um, let's go over the homework. I think I'll be fine, but if I say something wonky, it's because I'm on a significant amount of Vicodin right now. So just let that roll if I get confused or start babbling. Um, but I think all is going to be good. And for those of you who sent me messages, thank you. The surgery went well on Friday. I have another one this Friday and another one the Friday afterwards. So we'll by the time I'm done with that, I'll be the bionic man. Get my Terminator spine. All right. So let's go through the assignment and make sure we understand what I'm asking. I was mentioning here before class. Some of you probably found this assignment easy. You were able to connect the dots with what we talked about in class and go and do it. Some of you, when you first start getting in, I mean, all of you are beginning, or most of you are beginning programmers. You might have been confused or overwhelmed or intimidated or all of the above as you started getting into these things. I promise it'll get better, but you got to start ripping the band-aids off when we get into it. So every class will go over what I asked you to do and all that stuff. All right, so remember, kind of getting back into our notes here. We are back to this idea of how human beings solve problems. We remember things, we ask questions, and we repeat patterns. 100% of programming languages have facilities for these three things. Every programming language gives us a tool for remembering things, a tool for asking questions, and a tool for mimicking repetition. All right. What we're focusing on right now is learning how to remember things in a programming language. All right. That's what we're doing with this assignment. All right. So last time, as we jumped into C++, right into the deep end, right? That's the only way to get into programming is throw you into the deep end and hopefully you don't drown. All right, we went through these primitive types. These are the types that are built into the languages. Now, remember, I have this overarching mentality that programming is the skill set, the language does not matter. Okay, so as we look at these primitive types, I'm telling you that most of our modern languages come from the C programming language. So that means most of our modern languages have some subset or some form of all of these primitive types, even if their name might be a little different. Now, somebody did point out to me on this assignment, I went and updated the assignment. So for those of you who procrastinated just a little bit on the assignment, you maybe never knew the difference, but the assignment had you doing some things with the byte data type that online GDB did not support with C and C++. It was definitely part of the original C programming language. It then got moved into the standard library. So using namespace standard at the top that I did last time, that should have covered it, but it didn't. So I went through and I changed all of them that had you dealing with bytes to just dealing with shorts. But the lesson still stands in that we have 4 different ways in our modern programming languages, or in this case, we have 3 different ways in C, seemingly, to store whole signed integers. Signed meaning you can hold positive and negative numbers. Whole meaning they're integers, like the number 5 or the number -37, no decimal point stuff. Okay, so we have multiple ways of storing the same kinds of values where the difference between each of those is the maximum and the minimum value those data types can hold. All right. And the rationale was way back when memory used to be really expensive. So the programmers had to have the tools in order to, make sure we put our things we wanted to remember into the correct size box. Right. We're lazy and just say, hey, memory's cheap, so we'll just throw it in an int. And if that's not good enough, we will just thrown into a long, and if that's not good enough, we'll probably ask ChatGPT to do it. It's not a real true statement, but yes. Although we will get into situations where I'll look at ChatGPT and try to show it to you as a productivity tool for programmers. Super powerful tool. But the punchline is, hey, I mean, for the homework assignments I'm going to give you in here when we start programming, I can tell you with near certainty that a majority of them, you'll be able to copy the assignment, paste it into ChatGPT, and get a working solution. And guess what? Guess how you'll perform in the midterm? Not about the right answer right now. Once you get to my age and you've been doing this for 1,000 years, and all of a sudden all these things are boring to do, then you can use ChatGPT to do the heavy lifting. So all you have to do is the interesting problems that you're interested in. But right now you're still in learning mode. So you're only cheating yourself if you use ChatGPT. Maybe use it to double check your work. Maybe use it to, hey, if you run into a wall, get over the hump. It's like, oh, that's how that works. Those are great uses of ChatGPT. So I think so often, I mean, maybe you're seeing this in some of your other classes, your teachers are maybe viewing ChatGPT as the enemy, right? Don't use it, it's cheating, we're kicking you out of school, blah, 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 all this stuff. It's an awesome tool, as long as you're leveraging it the right way. I like to think of tools like these generative AIs. I like to think of them as augmenting your productivity. So I think if we roll forward, I don't think it's going to replace a ton of human jobs. Instead, it's going to make our current human jobs, the expectation of our people is going to be higher, because now they're not going to be wasting a half a workday doing something that is literally just throwing time at an easy problem, when you could just ask ChatGPT to write that code for you, and then you could focus on the harder problem that really involves a human being getting their hands dirty. Make some sense? So we'll look at some of those examples as well, but for right now, make sure your focus is in, you have to learn how to do this. Because eventually when you start leveraging ChatGPT professionally to do different things, you can make ChatGPT create something for you, but you need to know enough about what's going on to connect it in, to put it into your program and hook up the right wires so it all works. Okay? So in any case, we introduced these different ways of storing values. These are all of our types that are built into the programming language, our primitive types. Okay, and remember, C and C++, this is a strongly typed language, which means whenever we create a memory location, whenever we create a variable, we need to define the kind of value that variable was built to hold. All right, so this assignment had you drill those kinds of things. All right, we showed last class, let's see, the syntax for defining a variable. We have the type, followed by whatever you want to name your variable. This assignment told you what to name your variables. Then followed by an equal sign and the value. And that part's optional. We'll see that through some examples. You can bring a variable into existence without giving it an initial value, but you need to have a value in it before you can start using it. So you can define it on one line and give it a value 6 lines later, and then start using it. But keep in mind that you will only ever define a variable, we'll call it in the same scope, even though we haven't talked about that word yet, we will very soon. You can only define a variable in the same scope once. So once you've defined it, just like in your head, you all have a memory somewhere in your head, you've labeled a thing called my name, right? Everyone in here knows what your name is. Maybe you would name that variable in your head, my name. All right. So whenever somebody asks you your name, even though you're doing it so quickly, somewhere you're looking up in your brain, you're going and looking at that variable called my name, and you're pulling out the value stored there. For me, it's Mike, right? That's my name, is Mike. So I am resolving a variable because somewhere in my head, a couple of minutes ago, when I first started learning what my name was, I stored that away, and now I can access it whenever I need it. Okay. So we only defined that once. But if I went and had a name change, I guess now we're getting into some weird territory. But let's assume we did. I could overwrite that my name value in my head with my replacement name or something like that. Nickname, maybe, something like that. All right. So this assignment had you working with the primitive types. and practicing using the syntax for creating variables, storing values in those variables, manipulating those values, and then ultimately displaying those things to the screen, proving that the changes you made worked. All right, that was our goal for this assignment. All right, so let's take a look at it here. All right, so first step is we're going to define a bunch of variables using that syntax we just looked at. All right, let me make this a little bit bigger. Okay, that was mostly for me, not for you, so I could read it. All right, so we're going to have several variables here. So let me open up online GDB, this guy here, and I'll go ahead and just gut that for the moment. Now, one thing to point out that a couple people had asked questions about, remember last class, I added this line using namespace STD. If you don't put that line there, so this allows you to do something like cout hello world, as opposed to having to say standard cout hello world. This line right here says, make this namespace called STD available to this program. Therefore, I can call functions that live inside that namespace directly without having to fully qualify where they live. They're literally doing the identical thing. If you're going to do a lot of printing, for example, doing this using namespace standard makes it so that you save some typing without having to do the STD : thingy. Okay, but it's the identical thing. All right. So what had happened is a couple of people were getting weird errors on cout, and what they hadn't done is they hadn't added in that line that I did during class last time. Okay. And I realize, I mean, this is a lot of information that's getting thrown at you quickly, right? Hence the reason you have assignments to go and practice this stuff to, you know, figure it out kind of on your own at a certain extent. So, and it might seem like I'm going pretty quick with some of this stuff. So it's an easy thing to miss that I just threw that line in there, right? Go ahead. There is. I think I even mentioned it last time. I mean, inside of this STD namespace is a lot of different stuff, not just the cout function. So realistically, in this namespace, how many of its features am I using in this program? One. Okay. Yet when I said using namespace standard, when I compile this program and ultimately link it into an executable, even though that's happening behind the scenes here when I just hit the little run button, right? But it's going to create a much larger executable because it's brought in all those magic tricks from the standard namespace. So they're available to me even though I'm only using one of them. All right. So the rationale would be if we cared about our file size, there could be a world where we wouldn't want to just randomly include the entire namespace if we're only going to use one thing, especially if we're only going to print stuff out once or twice. Just put the STD : before it and move on with life. The reality is we don't really care about how big things are 99.9% of the time. We only care about the size of memory, things like that, when it becomes a problem, which does exist today, but it exists in the extremes. It exists in like scientific researchy stuff. It exists in like training large language models, things like ChatGPT, where you're using ridiculous amounts of memory, where it effectively puts us back into like the 1960s when memory was not that big and really expensive, because these large language models like ChatGPT, they use a ridiculous amount of memory to the point where it is a lot of memory by today's standards as well. All right. So that's kind of the game we're playing. There is a decent chance that in your entire professional career as a software engineer, you, depending on the kind of work you're doing, if you're doing business applications, let's say, there is a very good chance you will never, ever, ever run into a situation where memory actually is a problem in your programs. So throwing stuff inside of an int all the time or including the entire namespace just because, not a problem. Nobody's going to ever notice. You've used an extra 32 kilobytes of memory and that's just a rounding error or something like that. Okay. But so long-winded, but that's the rationale if you're looking for an academic side of it. Okay. So I mentioned last time what I like to do when I first have a program is just hit run, make sure this thing runs. And it looks like it is. Sometimes this happens. I need to go ahead and refresh this. I'll just paste my code back in there. All right, so I'll click run. We see hello world there. So we can say we're happy. We have a functioning program. We know all our development tools are working. So from this point forward, as we start working on the homework, any problems we run into is our fault. Make some sense? All right, so always make sure your tool's working first. Go ahead.
It doesn't execute when you.
That actually just happened, if you saw, because I tend to leave a zillion tabs open all the time. So sometimes as I move between internet connections or whatever, it kind of times out. So I tried to hit run a minute ago and it didn't run. So I just hit refresh in the browser. I copied the code just in case it didn't bring it back in because I hadn't saved my program here or anything. So I refreshed it, and usually with online GDB, that fixes it. You know, something like that. If we weren't using an online web browser. So just to throw a little bit more context here, what we're doing here is not the only way to program. In fact, it's not even, we can even say the common way of programming. If you go and work as a professional software engineer and you're doing Microsoft.NET stuff or you're doing Java stuff, you're not going to be using a website like this a majority of the time to do your professional coding work. You're going to be using, if it's you're a .NET shop doing like C# programming or Visual C++ programming, you'll be using Microsoft's tool called Visual Studio, which is effectively, it looks like Microsoft Word, but built for programming. All right, so it won't be inside of a web page here. It'll be a normal application. Java, probably one of the common tools for writing Java code is a tool called Eclipse. You go to eclipse.org, you can download that's for free. There's also another one called NetBeans. These are what are called IDEs, integrated development environments, which is a fancy way of saying fancy text editor for programming. That is, it doesn't try to capitalize things that should be lowercase because it assumes that syntax is funky and is not going to try to do those types of things. But those are the common tools you might use. So why am I choosing this? Well, there's even a bigger reason for something like C and C++. These are much older tools. We don't have modern, I guess, easy to work with compilers like Eclipse or Visual Studio for working with C. I guess technically we do C++ and Visual Studio, so we could have made that work. But in general, you would download a compiler like GCC, GNU C compiler is what that stands for. And it's all text-based. You would probably use like Notepad or some simple text editor to write your code. Then you go and compile it by hand. So you'd run it through the compiler, GCC, whatever the name of your file is, .cpp. It would then give you a executable because it did the whole linking thing. And then you would run that file by, you could double click on it or you can type in at the command line to run it. A lot of moving parts there, which has to do with using a computer, especially at the low level, working with like Linux operating systems and stuff, but not necessarily the focus we want to have in here, which is the focus on the programming aspect of it. So I don't have to support 20 different ways people are trying to do their homework. I use online GDB, which is a good tool since it allows you to switch between so many different languages. And now everybody's using the same consistent tool here. And you're going to see pretty quick how you can start submitting your homework moving forward. So for instance, if I want to turn this in, I can click on this share button right here. Give me the, oh, do I have to save it first? Just say save. There we go. So it gives me this link. So you can just submit that for your homework. And when I click that link, it'll bring your code up. So you don't have to copy and paste a whole bunch of code. The real world version of this that you would do professionally is using a tool called GitHub. Actually, the tool is called Git. The common website for holding those repositories of code is something called GitHub, which you maybe have even seen before, downloading some project or something like that. But effectively, this is probably using GitHub behind the scenes and creating a link for it like this. All right. So from an academic perspective, this website hits all the check boxes for us. All right. It lets everybody program regardless of what kind of operating system they use, whether you're a Mac, a Windows, a Linux user. As long as you have a web browser, you can go to this thing. It makes sure I don't have to debug 20 different people's installs of Eclipse or NetBeans or anything like that. And we can focus just on the programming stuff rather than all that other stuff, learning these tools, which are important. Okay, we're going to look at GitHub next semester when we get into the game programming stuff. So up till then, when we deal with C, C++, and Java, we're going to be using this tool. All right. Then as soon as we have to leave this tool to go to our game engine, Unity, all of a sudden now we no longer have the quick and dirty share button that gives us that stuff. Now we have to have a way of you submitting your game to me. And you're going to do that by uploading your code to GitHub and then submitting a link to your repository on GitHub. So we'll learn about that next semester. But what you're seeing is kind of the end result of that type of thing here. That part's automatically happening for you. So we can just focus on the programming stuff. All right. So first thing, we want to define some variables. We want a variable called age of type short. This is going to represent a person's age. Okay. So we're going to bring this variable into existence. So we're going to say the type is short, its name is age, and I'm just going to go ahead and stop right there. We're not putting a value into it yet. We could. We could say age is equal to 21, something like that. You could give it an initial value if you wanted to, but so far the assignment didn't say to do that. So let's just leave it at just defining a bunch of variables. All right. So now we're saying we're going to create a memory location. We're going to name it age, and it's built to hold a value of type short. And a short is a 16-bit signed integer. Okay. So next, a variable called year of type short to represent a year. So short year. Next one, a variable called population of type int that's going to represent a population count. So this will be int population. Next one, a variable called distance of type long to represent a long distance measurement. Remember, longs hold 64-bit signed integers. It's called distance. So long distance. Next one, a variable called grade of type char to represent a letter grade, like an A, a B, that kind of stuff. So char grade. This is the type. This is the variable name. Variable called temperature of type float to represent a temperature value. Type is float. Just say temp or temperature. I don't want to have to spell that. So type is float. Name of the variable is temperature. Next, a variable called pi of type double to represent a value for pi, 3.14159. So double pi. We won't give it a value yet. We might go back in and put some values in, but for right now, let's just define them, bring them into existence. And remember, the difference between the type float and the type double is similar to the difference between the type int and the type long. Longs hold larger values than ints. Doubles can hold larger values than floats, even though they're the same kinds of values, floating point numbers. All right. Variable called isStudent of type boolean. All right. So I just went ahead and ran that program. I got no output. Why? All programs begin and end with main. We talked about that last time, right? So when I hit run, what's actually happening behind the scenes? It's compiling my program. It didn't scream at me. So here, let me just purposely forget a semicolon there. Now I'll hit run. Now it's screaming, saying, hey, you've screwed up something. Okay. Now I think I'd already said this at some point, but this is part of that whole drilling thing because you're going to get a lot of these, right? As you're working on this stuff. So first thing to do is make sure you read what the error message says. Don't just go and randomly start changing your code because there's a problem. All right. This error says expected initializer before this closing curly brace. So before this guy on line 26. So it was expecting something to occur before this guy. So as I look at my code, I see, oh, I was missing something here. You'll get better and better at debugging those things because sometimes the error messages do read like stereo instructions. Where they're hard to understand. They're not as clean as you want them to be, but through some practice, you'll start noticing that they actually are pretty easy to debug a majority of the time. And usually if you just go to where it says the problem started, line 26, and then work backwards from there to things that might impact that, we stumbled upon where our problem was right there. But that'll be a skill in and of itself of getting good at debugging. All right. So when I run this, it runs. There aren't any errors, but I have no output. Why? All programs begin and end with main. Here's main. I go to line 1. What does line 1 say? Create a variable name age. So we created a memory location. Is there any output associated with that? Nope. I'm just labeling a little place in my computer's memory to store something. Same thing here, same thing here, same thing here, same thing here, so on and so forth. So by the time I hit the end of my program, I haven't actually done anything that would result in output that we'd see. A bunch of stuff has happened, right? Between line 15 and line 22, I created a whole bunch of variables. So I have done stuff. I just didn't do anything with those things that resulted in any output from my program. Makes sense? Makes some sense? All right. So I've defined a bunch of variables now. So now we want to perform some basic operations. So we want to assign values to the variables. So we can go through now and assign some values to these guys. All right. Now we have a choice. I'll kind of show you both versions of this. I can assign a value as part of the definition process. So I can say, short age is equal to 21. So now that guy has a value. But I could also do something like year is equal to 2024. Notice that I defined year on this line, and then I gave it a value on a different line. Notice I did not put the type again. You only need to type when you define the variable. When you just use it again, the type does not belong. So after this line right here, short year, a variable named year capable of holding a 16-bit signed integer has been brought into existence. It actually is given a default value. Usually it's a 0, but you should assume that it never gets a default value. Never write your code with the idea of the default value as part of your logic. If you want it to hold a 0, put a 0 in there. Don't rely on the default value being 0. All right, so we defined the variable here. We gave it a value here when you could have done that all in one line. Make some sense? Go ahead. No, because most of the time you're going to be using your own judgment for that. But most of the time, basically, this is probably the last time you'll ever write the variable short, is what it comes down to. You will almost always use int, and if that's not big enough, you use long, and you'll almost always use double. You'll probably never see a float again. When we get into the game programming stuff, you do see floats in there, but that's for kind of a different purpose. But the point is you should use the type, the appropriate type for what you're doing. And since we don't care about memory size too much anymore, typically if you're going to hold a signed whole number, you're going to put it in an int. All right. And if you're going to hold a floating point value, you're going to put it in a double. Can't necessarily give you the rationale of why int is the default on that side, but double is the default on the floating point side, because double's kind of more like a long. But that's what common practice is. All right. Okay, so we're going to give these guys some values. All right, so I'll space these a little bit. All right, so here's an example of defining a variable with a value all in one line. Here's an example of defining a variable and then giving it a value sometime later. It didn't have to be in the very next line. I could have put it all the way at the bottom of my code here. As long as I gave it a value before I start doing stuff with that variable, I'm in good shape. All right, population. This is an integer, so we would need to give it some value that fits in an int. So an int is a 32-bit signed value. So this could be some number between negative 2.1 billion and positive 2.1 billion. Chances are, since we're storing the value for a population, it's probably going to be a positive number, right? So let's just assume our population is 100,000. Just giving these guys some values, some reasonable values. Okay, distance, how far something is. Now, they mentioned this is for a longer distance because a long can hold humongous values, much bigger than 2.1 billion. So at the very least, I can do, that's 300 though, is that 300,000, that's 3 million, that's 30 million, that's 300 million, that's 3 billion. Which is bigger than an int could hold. Make sense? So if I had this as an int, oh, since I haven't used it yet, it hasn't been a problem. Let me just make sure I have this 300,000, 3 million, 30 million, 300 million, 3 billion. It should be testing that. Oh, but you could actually, I'm surprised it didn't give us that error there, but notice here, I put 3 billion inside that variable, and then I tried to print out that variable. See how this number is not 3 billion? Because what it did is it hit the end of what can fit inside of an int, which is 2.1 billion, and then circled back to negative 2.1 billion, and then started counting down from there, giving us 1.29 billion on the negative side.
So an overflow?
Effectively, it's an overflow. Yeah. Although I am a little bit frustrated that this really should have given an error, because we tried to put the number 3 billion in something that can't hold 3 billion. Let me go one number bigger. Okay, so this one gave us the error for overflow. Warning, overflow and conversion from long int to int. Oh, this is actually a more of a C++ thing. C++ allows you to kind of join multiple variable types together. We're going to pretend like that doesn't exist. If you ever need that in the future, it'll make sense to you then. All right, but again, this won't be a very common occurrence. Most of the time, you're going to be dealing with numbers between negative 2.1 billion and positive 2.1 billion. So an int is going to be plenty. All right. But the reality here was, since I tried to store 3 billion inside of something that's only supposed to be able to hold something up to 2.1 billion, and then when I go and print it out, we got an overflow error where the way binary math works, if I have the number 2.1 billion and I add 1 to it and it's of type int, it will become negative 2.1 billion. It'll like wrap around kind of like an odometer on a car. Makes some sense. And it's because of how binary works, how counting in binary works. If somebody wants to remind me after we kind of go through the assignment, I can go and actually show you the math, maybe with like an octal number or something like that. I just want to make sure I get through the assignment first. It's not really difficult stuff, but it'll make sense why it wraps around. All right. But for now, just know that if you have a 32-bit number and you try to put something in there that takes more than 32 bits to represent it, it's going to wrap the odometer around and get into the negative side. Probably not going to store the values you want to store, but this will rarely be a problem for you because I'm 99.9% of the time, you're going to be writing business apps or you're going to be writing video games, and you're not going to be working with these humongous values. You're going to be working with normal things that fit inside of an integer, counting to 3,000, counting to 10, that kind of stuff. Okay. All right. So since this is a long for distance, and we're going to go ahead, we're going to say this is, that is 300,000, 33, 300,000 there. That's 3 million, 30 million, 300 million, 3 billion. All right. So that's good enough. So realistically, this value is a value that's too large to fit into an int. We just saw that because it gave us the weird negative thing, but it fits inside of a long. So we'll just pick a big number to take advantage of the fact that it's a long. But we're holding a whole signed integer. It just can hold a really big one. All right. For grade, we'll give it an A. So notice chars have single quotes on either side. You gave an example of that in the assignment, but you'll get this through practice. So an integer type is just a normal number, normal number, normal number, normal number. The way we represent chars is using single quote followed by the character followed by single quote. It's a single character. But we've already learned in here that the way characters are actually represented in the computer is as a number, using either the ASCII character set or the Unicode character set. All right, and we can see that here. If I do cout grade, I'll go ahead and do this endl thing so it kicks it down a line. The internet die again? I did copy all that, did I not? Apparently not. I guess this is one of the downsides of using this is because if you're having internet connectivity issues. All right. All right, so here with my char grade, I'm going to write out grade here. I go ahead and hit run. There's my A. But just to prove it to you, let's go up here. And this is C and C++, so technically it's using the ASCII character set. So if I say ASCII character set, and here's our ASCII table. Let's just find it on a website that probably look cleaner. Here's the code chart for ASCII. Here's a capital A is actually the number 65. So what I'm telling you is what the computer is actually storing is the number 65. We can prove that to ourselves here by printing out grade again. But this time, I'm going to do something called typecasting. I'm going to force it to be an int. And notice we get the 65. Because when you, in a strongly typed language, when you say, hey, this variable is built for holding a char, from that point forward, whenever you use that variable, the computer will automatically go and do the lookup. Because this variable, grade, is holding the number 65. Even though we wrote single quote A, single quote, that is the number 65. That's what it's actually storing. But since its type is char, when we went to print it, it went and did that lookup for us automatically. In this second line here, I purposely forced it. I said, don't treat grade as a char. Go ahead and treat it as an int. Show me what's really in there. And that's where I got that 65. A majority of the time, you're not going to have to do that either, right? Usually, if you're going to create a variable capable of holding a char, it's because you wanted to store a char. And you're going to be thankful that the computer does the mapping for you, goes and looks it up for you and all that stuff. But this is more of us just peeking under the hood and seeing that things I've told you about how it already works is how it works. Okay, go ahead.
So when you're working on code, how long should you save? Like every 15 minutes, 30 minutes?
I would say, I mean, I tend to save pretty often. I think actually the site does auto save for you, but confirm that because I'm sure the site updates reasonably often. I would treat it like you're writing a paper, you know? So you learn the shortcut key and you just constantly are hitting save between it. In fact, you'll see me do it sometimes because when I hit save, see on this guy, you know, I forgot I was in a web browser. So when I hit save, my expectation was I was saving the code, but that's not what actually was happening. It was like I was trying to save the web page from Chrome. All right, but you'll get into the habit. I would say save often. Yeah. Maybe especially if you're on campus doing Wi-Fi and you might have dropped signals or something like that. At the very least, you've seen me do it a couple of times today, even though it backfired the last time. But if it does start behaving funny, where I think the fix is to hit reload for the site, I went through and I copied the code first. That way, if it reloads and it doesn't bring it back, I can just paste it back in there and pick up right where I left off. All right. But mentally treat it just like you're writing a paper, probably. All right. So any questions on this? And this is stuff that I'm not going to necessarily directly test you on. This is really things that I'm trying to connect the dots about the stuff I've theoretically taught you in class about how things are actually stored, and then you seeing that that's a reality. Okay, because our goal as computer scientists is to understand what's going on under the hood. I want you to understand this stuff. All right, but there's a very, very, very good chance in your entire career you will rarely ever do something like this. If you created a variable to hold a char, it's because you wanted a char in there. The fact that it's actually stored as an int isn't important to you. But I'm proving that this is the case. If you had started programming years and years and years ago, sometimes you would use some of these things like this to like pull off tricks, stuff like that. Like, for example, technically, the way we can store a byte in our code here is through the char primitive type. I can store positive bytes. It's an 8-bit number as a char. Even though it didn't let me use byte as the data type. It just keeps me from holding a negative number. All right. So I won't ask on a test for you to write some code that shows me the Unicode or the ASCII version of a char. But you should appreciate that this is what's happening. All right, that's not showing me that you know how to code. All right, so we gave a value to our grade. Temperature, this guy's a float, so we got to give it a floating point value. So for temperature, let's say this is going to be 45.2. Okay, now let me give you a little word of warning. If you were dealing with a newer language than this, like Java, this very well may have thrown an error. Because 45.2, isn't that also a legal value for double? They're both floating point numbers. They both fit within the footprint of what a float can hold, right? Okay, so how does the system actually detect the difference between a float and a double when both of them are legitimate numbers? In a lot of newer languages, what you would do is you throw an F on the end of that. So it's still cool with that, but it kind of did it for us because I labeled it as a float here. I didn't have to put the F here. It just said, oh, you must mean that this guy is of type float because you defined it as of type float. But when we get into the game programming stuff, some things are from very old libraries where you did actually have to specify whether something was a float or not. And so what you'll see sometimes is something like that, 45.2F. So if you ever see that in any documentation or something like that you're working with, what it's doing is it's saying, this is a floating point value, not a double. There is not an equivalent for that for doubles. So if you leave the F off, leave the F off. It's fair game for it to be a double. All right. In fact, just for consistency here, I'm going to go ahead and leave the F in. I think that's going to be more common than not. But the good news for you is this very well might be the last time you use a float on purpose. You're going to almost always be using doubles. Therefore, it won't even matter. You just write your floating point number. It'll take up extra footprint in memory than it really needed. And you move on with life because you don't care about memory. It's somebody else's money, right? All right. So then a double for pi, 3.14159, which would also fit inside of a float. But there's our value for pi inside of a double. And then boolean for is student, we'll throw in a true. All right. So there's us defining a bunch of variables and putting some values in those variables. Questions about this so far? Just kind of going down the list for the assignment. All right. So back to the assignment now. Now we want to perform some basic operations, do stuff with these variables. Okay, so we already assigned some values to the variables. Now we want to add age and year together and store the result in a new variable combined. I don't know if that meant name it combined or just a variable that is a combined thing. So this is age and year. So I'm going to go ahead. Age is a short, year is a short. So as long as these two values could fit inside of a short, I can go ahead and make my resulting value also a short. So I can do short age plus year. I'll just name it as the full thing. And this is going to be age plus year. So I've created a brand new variable. I just happen to name it age plus year. This naming convention is something called camel case. These are like the humps of a camel. So a lot of times programmers, you should have variables that have meaningful names. Like you don't want to have a variable that just says int a, because a might not mean anything, right? So in this case, this variable is built for holding the sum of age and year. So I happen to call it age plus year, and using a capital P and a capital Y here makes it a little bit easier to read. So this is a naming convention, not something that's part of the required syntax for C++. Go ahead.
Before where you actually said age plus year, couldn't you put a plus sign in between?
Oh, you want to do this guy? Oop. Like that? Yeah. Nope, that's a reserved value inside the language.
Okay.
So the plus sign is already, C++ says that's how we do add math.
Oh,
we also do it for concatenation, another thing we haven't learned about yet. But basically it says this is off limits for your variable names. Can't use the plus sign for that because we've reserved it for something else.
Oh.
All right. Now I just chose to name this variable age plus year. Some of you may have called it combined because the assignment kind of sort of implied maybe that's what it should be called, but doesn't matter. Point is, we created another variable to hold the sum of age and year. All right, we can go ahead and test that. Print out age plus year. And in this case, we should get 2024 plus 21. So this is 2045. So there's our 2045. the sum of those guys. All right, so add age and year together, subtract distance from population and store the result in a new variable called difference. Okay, I'm going to start naming them those things. So actually, just to be consistent, let me name this guy combined. All right, the next one we're working with is a variable called difference. And this guy is subtracting the distance from the population, storing the result in difference. Population is an int, distance is a long. So we're taking distance minus population, so the result could be a long, right? So we're going to choose our type here. We're going to say that the type of value will be long. It's going to be called difference, and it's going to be equal to distance minus population. And I purposely chose long here because distance was a long value. Now, keep in mind, when you're using variables, when you're writing your code, you might not necessarily know what value that variable holds. We might be in the middle of writing code that's part of some function where somebody else passed us a value for distance. And as the human being coding this, we don't know what's actually stored in that variable. We just know that it could hold a value up to what a long can hold. So that means that a long minus an int potentially could still be something bigger than an int can hold. Make sense? So we then chose long as our final variable type to store that difference in because it might be a long and we might need all those things. In this case, we would have, right? So if I see out difference, we're going to see that difference between those two values. But if I change difference to an int, notice it went negative again because it didn't fit. Because that's the overflow thing. We tried to store too many bits in something that could only hold 32 bits. Took more than 32 bits to represent that number. So what did we end up with? We ended up with only the first 32 bits of it, and it happened to have a 1 at the beginning, so it was treated as a negative number. Any way you cut it, we tried to put too much stuff into our bucket. So that's why we logic through it and decide, okay, we have a long minus an int, so the answer might be a long, so we'll store the result in a long. All right, and then we get our actual reasonable value. All right, next, perform integer division on year by age and store the result in a new variable. So we want to do year divided by age, storing the result in a new variable called div result. All right, so year and age are both shorts. So the answer would likely be a short. In reality, you probably would put it in an int, but we'll stick with the short thing just to drive that point home. So we'll say short. The variable is called div result, and it's going to be, which is a year divided by age, year divided by age. So now year is 2024. Age is 21. 2024 divided by 21 is 96.38, blah, 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 blah. But since that answer is going inside of a variable of type short, which can only hold whole sign numbers, it's not going to be able to hold the decimal point value of that. So instead of it holding 96.38, it's going to hold a 96. Keeping in mind, I mentioned this last class, it is not rounding. It is doing something called truncating. It is just cutting the decimal point off. So even if this value is 96.99, it would cut off the 0.99, it would be a 96. It is not rounding, it is truncating. All right, so we'll create a variable of type short called div result. It's going to be equal to whatever the year currently is divided by whatever the age currently is. So if I go and print this guy out, we'll see that 96. There's our 96. Truncated. And we can actually see this in well, I'll wait for a better example for that one. All right, so questions about that? So that's integer division. Integer division gives you, if you remember back to 3rd grade math with long division. So this would be 2024 divided by 21. So you would do long division, which would end up being a 96 with a remainder of something. Remember that guy? Okay. So we actually have, I don't remember if I have you do remainder in this, but if I also wanted to have a short remainder, oh, can't call it that. So reserve word, call that div remain. And this will be year, something called mod age. So these two are complementary operations. This first one says take year divided by age and store the whole number part of that. The second one says take year divided by age, but give me the remainder what's left over. So if you were doing this as long division, div remain would be the thing that comes after the R when you write it in long division. A little space there. We'll call this guy div remain. So technically, well, actually, if you really want to see the R. So this is 96 remainder 8. That's what that integer division is. Whenever you need to do remainder stuff for integer divisions, which is actually going to be shockingly common in coding. We use 3rd grade math long division, specifically the remainder portion of that pretty often. All right. And we already saw this in converting numbers, right? When we were converting from a from decimal to any base, we kept dividing by that base, recording the answer and recording the remainder. Okay. All right. Modify the value of grade by assigning it a new letter grade. Okay, so we're going to change an existing variable. Now we look at grade. We see I started off as an A. So now down here, I'm going to say grade is now equal to a B. Notice I did not say char grade because grade has already been defined as of type char. This would be inaccurate. If I try to run this right now, it's going to tell me that a variable grade has already been defined in this scope. Redeclaration of char grade. So it'll be happy to scream at you if you try to redefine the variable, but that's what's going on here. I brought that variable into existence up here. So now if I'm going to change the value of it, I just reference the variable name. And then this is the assignment operator. So I'm assigning the value B to overwrite the value that's currently stored in this existing memory location. All right. Modify the value of temperature by subtracting 5.5 from it. We'll say temperature is equal to temperature minus 5.5. And if I'm staying consistent, I'll say 5.5 F. Since I'm doing stuff with floats, I'm letting C++ know that this is a floating point value, not a double value, even though it didn't actually make a difference. I'll do a C out on temperature here. And nothing keeps you from printing out multiple things at once. Just Since I'm not putting endels on them, they'll all run together on one line. So we'll print out temperature here. We know temperature used to be 45.2. So now we expect it to be 39.7. That minus 5.5. All right. Modify the value of pi by adding 0.001 to it. One thing I'll point out here, and I'll show you again in pi. I am changing the value of temperature here. So the assignment operator is what the single equal sign is. Single equal sign is the assignment operator, which means whatever's on the left-hand side of it is going to have a value assigned to that. We're overwriting the value inside of temperature. What are we overwriting it with? Whatever the current value of temperature is. So that's going to resolve to the current value of temperature, which is 45.2 minus 55.5. All right, so we see this variable here twice. This is where we're overwriting. This is what we're assigning the value to, but we happen to be using its old value as part of that assignment. There's actually a shortcut way of writing this that you never have to use if you don't want to, but I'll show it to you in case you've seen it before or whatever. You can say temperature minus equals 5.5x. These two lines do the identical thing. So this is a compound operator minus equals, which say subtract and assign. That's what that does. So this little shortcut, if you were to spell it out, I might call this syntactic sugar. If you were to spell that out, it actually is doing exactly that. All right. Again, I'm never going to test you on that. You won't have an assignment where I say you must use compound operators. Use whatever makes the most sense to you. I'm just showing you things that you might have pop up to you when you look at documentation or something. These guys do the same thing. All right. Here, I'll put a couple of front slashes before that. Notice it changed color. That's a comment. Single line comment, you put 2 slashes. So that's for human eyes only. We won't, that won't get compiled or have syntax errors or anything like that. It just ignores it since it's a comment. We'll see plenty of examples of that. All right, so we're modifying the value of pi by adding 0.001 to it. So we'll say pi is equal to pi plus 0.001. And pi was a double, so the default in most programming languages when you say a floating point number is a double, so we don't have to say anything special after that. In fact, there isn't a way of saying treat that as a double. There's only a way of saying treat that as a float, which actually would still be allowed because a float is of the same type. It just can't hold as big of a value. Okay, but this is pi we're overwriting pi. We're assigning a new value to pi, and it's whatever the current value is plus 0.001. All right, so now toggle the value of isStudent from true to false. Okay, show you a couple different ways of doing this. So this guy's called isStudent, and it's already equal to true. So we can set it to false like that. But we can also do this a different way. We could have said isStudent is equal to not isStudent. So this kind of goes along the lines of the toggling thing that it was talking about. Not isStudent just flips whatever it was. So not true is false. Not false is true. Okay, so these are boolean operators. We'll be messing with these a lot because we're going to be, when we start asking questions here pretty quickly, we're going to be using boolean operators. When we start writing loops, we're going to be using boolean operators. So we're going to have plenty of practice with this. I don't think this was probably the intent for the assignment. It just said change it from true to false. So there we go right here. but this is the thing. I'll come to you in a second. What's up?
So that's the exclamation point,
That is an exclamation point.
okay,
Yeah. The exclamation point is the not operator.
alright, and then it just, for the opposite of not, do you put like a, like,
Well, there really isn't an opposite of not. I'm gonna add some stuff to our slides here related to this, but go ahead.
Would you be able to run it with both of those on there, or?
Well, I mean, absolutely, because
Okay.
I mean, what am I doing? Actually, here, this will be a good test question. What's it gonna print out right here? Line 46 is gonna output something, right? It's gonna print something to the screen. I think it is gonna show a true or false, but it might be a 0 or 1, because in C and C++, under the hood, it stores it as a number, 0 or 1. Okay, but so regardless, which of those is it? 1? Okay, so let's follow the logic here. Is student started off as true? We changed it to false here. Then we changed it again. We changed it to be whatever not is student is. So what's not false? Not false is true. So after this line, this value is actually true. And we see the value for true is 1. If we were doing that in a newer language or a newer compiler, it would have translated the 1 into a true. But in all new languages, Java, C#, you don't see the 0s and 1s. For booleans, you see trues and falses. Some languages also, instead of true and false, it uses yes and no. All right, but so to answer your question, you said, can you do them both? All programs begin and end with main. We walk it line by line. We define that variable up here. We changed it here. We changed it again. Then we printed out the resulting final value. So they all are having an impact, right? It's not like we just did these separate things. Oh, which is it going to choose? It goes in order. We can change that variable 500 times and then print it out once. We're going to get the final resulting value after all the things we tried to do to it. Make some sense? All right. So then it had us printing out a bunch of stuff, the value of age and year, of us combining them together. We did a bunch of the printout stuff as we went along, the value of population, distance, the result of subtracting them. We saw that too. So you can have 50 print statements if you want. All right. So any questions on the assignment? Okay. Well, okay. So, but the important thing here is, so I mean, some of you maybe had some background in programming. When you went to do this homework, it was probably easy. It's like, oh, okay, this is a softball. But for the rest of you, where this is your first time you've ever seen coding, right? This is an intimidating thing because, okay, what's this guy's just throwing variable names around? He's talking about floats and shorts and doubles, and these are all foreign terms to me, you know, so you're overwhelmed with it. But so the point is now that you've seen it, hopefully that it made sense to you. What's going to happen as you're learning the program is it's going to make sense when you see the right answer way before you're going to be able to write the right answer yourself. So you'll see me do it in class. You're like, that's it. But then the very next assignment, you're going to feel like, okay, I still suck at this. That's normal. That's the process. One day it's going to click. I promise. Go ahead. I don't care. Yeah, I mean, the implication was, since they said distance should be a long, the idea would be it was meant to hold a humongous number, but a long can hold the number 5. There's nothing wrong with a long holding 5. It's just incredibly inefficient for memory. You're using 64 bits to hold the number 5. But who cares, right? So the thing we should appreciate about this, based on the slides we've had from the last couple of classes, is at the very least, when you define a variable and say it's of type long, that dude is capable of holding big values. Nobody says you have to put a big value in there, right? You can get a a giant, we were talking about the examples of like getting the giant bucket for holding your taxes and then put a single Post-it note in there. Just say, okay, that's what it holds. You're not using the space very efficiently, but man, that Post-it note easily fit, had some elbow room, right? No problem. Go ahead. Well, not in your variable types, because it's not something we know even exists. You know that like Fahrenheit or centigrade exists, right? So what you would have to do in this case, oh, sorry. So I chose to put 45.2 F in here. Well, to your point, we don't know if I'm talking about Fahrenheit or I'm talking about centigrade or I'm talking about Kelvin. We don't know what I'm saying there, right? We have no way programmatically to say that because this is just math stuff. It's not dealing with those things. So maybe let's assume I meant this to be Fahrenheit. I can maybe put a comment before this and say temperature is in Fahrenheit. You spell Fahrenheit. It doesn't look right. Just throw a couple other T. Yeah, see, if you're gonna misspell something, misspell it bad, then it looks on purpose. All right, so you could put a little comment in like that to remind you later on what kind of value you put in there or something like that, but that's for your eyes only. At some point you have to connect the dots and say, hey, I wanted to remember something here. Keep in mind, that's the purpose of variables. We want to remember stuff. So I created a variable capable of holding a temperature. I had to know that the temperature I was holding was Fahrenheit. I had to keep track of that. All right, make some sense? All right, so, oh, there, I did it again. So let me introduce a couple of things in preparation for next class. Next class, we're going to start getting into Boolean expressions and asking questions. So we go into the slides here, and we're going to put in something called Boolean expressions. A Boolean expression is any expression that boils down to a single value of true or false. Now, this is going to be one of our mantras. Okay, might seem stupid, but I'm going to ask this. You're going to hear me ask this when you're seniors. And eventually it's just going to be like, okay, what's a Boolean expression? You're just going to say true or false. So it's any expression that boils down to true or false. And the reason I'm harping on that is you might have code that puts together a whole bunch of different stuff using a whole bunch of different operators. And those things, it might look really complicated. But at the end of the day, it boils down to one value of either true or false. That is a Boolean expression, regardless of how scary it initially looked. But at the same time, if we come here to is student, I say Boolean is student is equal to true. Is that a Boolean expression? It boils down to a single value of true or false. It's not an overly interesting Boolean expression, but it is a Boolean expression. All right, so some of the things we're going to mess with next class, besides Boolean expressions, is we're going to look at Boolean operators. So we're going to look at and, or, not. But then we're going to look at the place where you run into errors. So this is an and. This is an or. This is not, which we saw today. But these guys right here, this is a bitwise and. This is a bitwise or. So we're going to look more closely what that means. Because wouldn't you agree, especially as a beginning programmer, if you're writing a Boolean expression and you meant to say, well, is something true and is something else true? Is it fathomable by you that you might, instead of writing 2 ampersands, you might just write 1? That's a pretty easy mistake to make, right? Especially when you're just starting. What's going to be frustrating about this is not an error. You're going to get a weird number. So we're going to talk about why you get a number. We're going to look at what bitwise operations are. And good news is you may go your whole career and never use them. But we're going to understand how they work. All right, go ahead.
How come there isn't the bitwise not?
Well, once you see bitwise, it'll make sense. It wouldn't make sense for there to be a bitwise not.
Okay.
Yeah, it's there actually is a bitwise exclusive OR. That's this is bitwise XOR. So this is not taking something to a power. Again, another common mistake, right? You might think I'm doing something to the 3rd power or something, yet all of a sudden you're just getting a math answer. Like, what the heck is that? Right? It's because it did a bitwise exclusive or whatever that means. It's not actually difficult, but knowing what's actually happening on the hood is helpful. All right, questions, comments, concerns, bribes. All right, make sure you review the stuff we went through today. Make sure you kind of feel confident in what the last assignment looked like, regardless of your emotions that you went through it. We'll introduce some new stuff. We'll have another assignment over the weekend dealing with if statements. So we're going to introduce asking questions.
Okay.
All right.
Yeah, now that I saw it, I'm like, you gotta be kidding me. Yeah, I feel,
Actually, I have one more question. So
Sure.
when you're typing stuff, like when you add age plus year, you put spaces between age and the plus.
Not required.
Are you just doing that to make it neat for the class?
Yeah, and it's also, I would say, convention. I mean, most people, you want your code to be as readable as possible, but all your modern languages, they don't care if you put your whole program in one line.
So when you type code, do you put the space?
Oh, yeah.
Just to make it look neat?
I'm writing code the way I would write code.
Because I was
and-
thinking it might be easier if you're typing a lot, it would be easier to like.
Yeah, I get what you're saying.
But
Once you get to the point of like coding maturity where you can make that choice, do whatever you want. I'm not gonna take points off if you have an
Yeah.
extra space or something. But the example I'll use when we get to it, especially with like indenting and stuff, is I am not an overly organized person in general, yet I organize that. So if I'm saying it's important to organize it for human readability, it's probably pretty.
and I guess you
important.
mentioned before, you're gonna get a bunch of errors. You want to be able to read it the best you can. So you
To
can
bug
avoid
it,
that.
right?
Okay, that makes sense.
Yep.
All right, thank you.
What's up?
This is the code
Yep,
which I did it with the help of Google
that's fine.
and ChatGPT.
Yep,
Okay. Because I wasn't able to understand.
that's fine. I get it.
Okay.
Yep.
So yeah, I did it in this way. Okay, I entered my age and
Yeah, I see it.
these are the random numbers which I
Yeah,
gave.
got it.
and just the random
So what's the question?
Okay, so this is the one, and this things like appear. I don't know. I didn't get this part.
Okay,
the-
so it's outputting a bunch of stuff. This is something that, this is called an inline if statement. I'll introduce this at some point, but this is pretty advanced stuff.
Yeah,
Um,
I didn't get this stuff. because
Yeah, I get it.
this is from
And part
ChatGPT.
of that is because you're getting your answer from another source.
Yeah.
Go back to the
this is
code.
this is the-
I understand, I'm with you. So when you output this is outputting the word age, followed by a space, followed by the value stored in age, followed by a space, followed by a comma, followed by a space, followed by the word year, followed by the value of year, followed by space. It's just building out a string that looks pretty.
So.
So
it's
ultimately,
necessary-
this will output age, some number, year, some number, combined, some number, and done.
Oh, okay. See, this is how I got from
I get
watching
it.
the class video which you
Yep.
uploaded again. I don't know why it's taking today so long to, just load the page.
Yeah, the internet seems slow.
Oh, it's very slow.
But I've already connected the dots. I know exactly what you did.
Like, I didn't get it that part, and when I watched it, your.
Do you
video
understand it
only-
more now?
Yeah, I was able
Then
to
you're
understand it.
you're right where you need to be.
So it's not loading the page.
Yeah, I get it. It's fine.
Yeah. Yeah, it got loaded. So yeah, from your video,
Yep.
I did remove this one, but when I was removing this, the
Th-
code didn't
This
work.
is something different. This is called an inline if statement. This
Mhm.
is saying if this is true, boil down to true. Oh,
Mhm.
actually, this is saying if this is true, boil on the false.
Yeah,
Um, I will explain that when we get into if statements next time, but that is a different kind of animal.
Yeah,
So I would just say,
didn't get it.
don't worry about it right now.
yeah,
Alright.
I didn't get it, so I was asking, you,
Yeah.
and I did upload the assignment, so.
Yep.
So that's the reason. Okay, thank you very much.
Yep. What's up?
Class.
What's going to be the hardest
Yeah.
thing in this class? Well, I mean, I don't know, what does hard mean?
Whatever you.
Like how complex are we gonna get? Pretty complex, pretty quick. By the end of this class, usually kind of near the end, we're writing, kind of our own Dungeons and Dragons-y type thing where we have multiple rooms linked together, north, south, east, west. We have our guy moving around in there. We'll introduce the idea of multi-threading.
Okay.
So, yeah, so I mean.
Learning about that yesterday.
Yeah, so I mean, we get into, yeah, I mean, you talked to Noah or Brocker, I mean, it was, we called it our dungeon crawler
Yeah,
is what that application was, so,
okay.
yeah. I mean, so if you've had some of this stuff before, this is gonna seem pretty primitive to you right now, but we ramp up pretty quick.
That's good. I just taught them very well. They're very good teachers. Yeah.
What's this?
You taught them very well. They're very good teachers. They like remembered everything you said.
Oh, you're hearing like repeats? I've been doing this for a few minutes. All right.